starting the class. Okay, so the last topic which we were doing in the last class was the strength of non-oxoacids. So how to compare the strength of non-oxoacids? Remember we did the strength of oxoacids? Okay, Azuni, that's not the right answer. If it is oxoacid, I think you're giving me for oxoacid, right? For oxo means oxygen containing, or you can call it as oxyacid also. Oxoacids, you're going to compare the oxidation number and you're going to compare the electronegativity of the central element, central element. And we discussed many questions based on it. But in case of non-oxo acid, that also we did in the last class. In non-oxo acids, you're going to compare across the period. Across the period, which factor is dominating? Remember this, across the period, it is the size it is the electronegativity which is dominating factor, not the size, sorry. Electronegativity which is dominating. And yes, Azuni, down the group, it is the size. Okay. Now, if I give you H2S and HCl, which one is stronger acid? These are non-oxo, without oxygen. So which one is stronger acid? H2S or HCl? Because this is across the period. You look at the periodic table, sulfur and then chlorine. They are in the period number 3, if you remember. And you can check the periodic table. So chlorine is more electronegative. So across the period, you are going to compare the electronegativity. So it means sulfur with 2 hydrogens and this hydrogen on the chlorine. Who can pull the electron density more strongly? Chlorine. Chlorine is more electronegative, so it will pull the electron density on itself. Please understand this concept. More electronegative atom can pull the electron density more strongly. But this factor is dominating only across the period. But if I ask you to compare H2S with H2SC, here, this one. In the periodic table, below sulfur, there is selenium. Afan, which video? 11.2. I didn't place it. Okay, I'll put it today. Oh, you can remind me on the WhatsApp also. Okay, children, please don't hesitate in reminding me about the videos on WhatsApp. Okay. Because I have to update the videos of so many groups. So sometimes I feel that I have updated. And if you remind me on the WhatsApp, I will ensure that I check and I update it again. Because I think that I updated. I don't know. I'll check it. Maybe sometime I put them on my YouTube channel because generally I'm placing them on the channel first and then I'm taking the link on that quiz center. So sometime I place them on the YouTube channel, but forgot to place the link in the center, quiz center. So I'll check Afan and I'll do it. Okay, so now we are moving down the group. So moving down the group, what factor is important? Size. So Aditi is already answering. She's saying H2S is H2SC. That's what you're saying? Yeah. She's saying H2SC is the stronger acid. Is the stronger acid. Okay. Okay, now let's try to understand the reason. She's right, H2SC is the stronger acid. Now, what's the reason? The reason is as you move down the group, size increases. See, down the group, size is the factor. And now this hydrogen, which is bonded with small atom, this hydrogen, which is bonded with, this is hydrogen, right? Hydrogen. There's hydrogen here also, hydrogen. There's hydrogen here also. Now the bond length, the bond, when I draw it in the form of this line bonds like this is sulfur and this is selenium. As the size of the atom increases, size is more, size of orbitals. What will happen to the size of orbitals? Will be more, big size, big orbitals. Means bonds are longer. Longer bonds are weaker, weaker bonds, and easy to break. So please understand this. If size is more, this is down the group only. Size is the factor all the time down the group. If size is more, orbital size will also be big. Bonds formed like this bond is longer. Bond is always from this center to this center. This is bond. This center to this center. This is bond. You can see as the size increases, bond length increases. As bond length increases, it becomes weaker bond. Weaker bond means easy to break. Easy to break means more acidic. You can take out hydrogen more easily. So please, these things we did in the last class, Sunday extra class. Now we are going on some questions which we already started. Like if you remember, this question we have already done. Okay, can you answer it again? So first you check, are they oxoacids or non-oxoacids? They are non-oxoacids. So are they in the same period or group? They are in the same group. Oxygen, sulfur, selenium. In the group, what are you going to compare? The size. So which one is the strongest acid? H2SC. So that's the order. H2SC is a stronger acid than H2S, which is stronger acid than H2O, right? Can you make the conjugate base of this? Make the conjugate base of this. What's the conjugate base? H, remove hydrogen. You remember to make the conjugate acid to conjugate base, remove H plus. HSC minus. Very good. What's the conjugate base of this? Yeah, all of you please try it. HS minus of water, HO minus. Okay, now which one is the stronger conjugate base? This is the acid order. This is the strongest acid. Stronger acid will give you weaker conjugate base. Yes, you're right. OH minus is the strongest. Yes, very good. Perfect, children. Afan, very good. Okay, so now let's do the B part. In the B part, I know it's a very different question, but I want you to think and answer. So I'm not helping you much in this question. I'm just showing you in writing that what is there. So can you tell me in this compound which hydrogen is acidic? In this one, the first one. Which hydrogen? You can see so many hydrogens. Which hydrogen is acidic? Think and answer clearly. The last. What do you mean by the last? And then I will ask the reason also why. What do you mean by last? The one on the oxygen or the one on the carbon? This hydrogen is on the? Yes, it is OH. Yes, Nivriti, very good. It is OH. So the one which is on the oxygen is more acidic. Can you answer this? Why? Why is it so? Why is it so? Because the one which is bonded to oxygen and the one which is bonded to carbon, out of these, which is more electronegative? You're in the same, you're in the same period, oxygen carbon. Oxygen is more electronegative. So it's going to pull the electron density more strongly on itself, correct? It's going to pull the electron density and going to release hydrogen as H plus more easily. Okay, now based on this understanding which I have just given you, can you answer which one is the strongest acid here? This is important question. If you see here, they all are oxygen containing acids. So in all the cases, the hydrogen is on the oxygen. This part is not changing. So focus on the change and then think and answer. So don't compare oxidation numbers. Don't compare electronegativity here in this part. It's not changing. Even the oxidation number is not changing. Focus on the change. What is the change? Who is there in place of Aditi, in place of hydrogen? Who is there? Like this one has 3 hydrogen. This one has 2 hydrogen, 1 fluorine. What's the effect of the fluorine? What fluorine can do? What is the nature of fluorine? Look at the periodic table. Do you know anything about fluorine? It is the most, yeah, it is the most electronegative element. The most electronegative element of the periodic table is fluorine. Remember this line. So what this fluorine is going to do? Is going to pull the electron density very strongly, like this, on itself, which will pull the electron density from this carbon, then from this oxygen, and then from hydrogen. It's a chain effect like this. This fluorine is pulling electron density on itself. Yes, Azuni. Azuni is saying this is the most electronegative. Azuni, can you tell me why? So children, I'm going to show you the structure. If you don't know the structure, doesn't matter. But they can give you the structure, okay? This is an organic compound. This is the Lewis dot structure of the molecule. Now this one has 3 fluorines, you can see. Okay, and you know about fluorine. It is one of the most electronegative element. It's going to pull electron density from the carbon, this carbon, which is like this. This carbon is very, very electron deficient. It's going to acquire a positive charge. So it will pull electron density from this carbon. Then it will acquire a positive charge. Then it will pull electron density from this oxygen. And then oxygen is going to pull, because oxygen doesn't want positive charge on it. Oxygen is also very electronegative. So it's going to pull electron density from the hydrogen. And it will kick out hydrogen. Oxygen will kick out hydrogen as H plus. Right? This is called as, actually it is in organic chemistry. When you're going to go for higher classes, we have a term for this. Can you see that this effect is operating through bonds? And more you come closer to this hydrogen, more closer to these fluorines, if they are more closer to these hydrogen, more stronger is the acid. It's operating through bonds. So electronegative atoms more closer to acidic hydrogen, more stronger effect. Can we write down this example, this picture? You draw this picture and write down. Write down this line. More electronegative atoms more closer to acidic hydrogen, more stronger acid. And draw this picture, this one. And please write on this, because I'm going to erase everything and I'm going to place a question based on this concept. Yes, Azuni, your answer is perfect. Language is good. 3 fluorines means a very big number of electronegative atoms pulling electron density very strongly, making carbon highly electron deficient, which will pull electron density. It's like a fight for the electron density. And who is the sufferer? This hydrogen. The hydrogen will be kicked out as H plus because everybody is asking for electrons. This part is done. Can I erase this? Afan, can I erase? Can I clear the whiteboard? Okay, good. Here is the question. Very carefully observe and then answer. You know that which hydrogen is acidic? So say the hydrogen on the oxygen, right? Hydrogen on the oxygen is acidic. And the hydrogens on the carbon, like these hydrogens, they are not acidic at all. They are not acidic. Okay, this is one example. This time I'm placing chlorine. Second, third, this is organic molecule, children. Don't worry, if they give you any question based on organic molecule, they will give you hints. You can understand. So structure 1 is an acid, structure 2 is an acid, 3 acid, 4. Can you arrange them in the order of increasing acidity? Which one is the strongest, which one is the weakest, and what is the reason? Yeah, first give me the order. Or first you tell me which one is the strongest and why. See the change. This hydrogen is acidic. But this part is not changing. So focus on the change. change can help you. The change is this chlorine, which is moving like this. Okay. Remember when we were discussing these fluorines, three fluorines, I said is operating through bonds. Can you read the sentence which I gave you, Azuni? Can you read the sentence? More electronegative atom, more closer to acidic hydrogen, more stronger acid because it's operating through bonds. In which case, this electronegative atom is closest to this acidic hydrogen. In which case? Yes, yes. So which one is the most acidic? Yeah. Can you put the order now? Nivriti, try to answer. Put the order. These are the concepts which you can learn, understand with me only. You'll find it difficult otherwise. Nivriti, are you there? Yeah, answer it. If you have understood, answer. So, 4 is the most acidic, then 3, then 2, then 1. And 1 is the weakest because you can see that there is no electronegative atom. So, the line which I gave you, I made a box, I said, write it down, understand. The question is based on that. More electronegative atoms, more closer to hydrogen. Ready for next question, children? Okay. This one, C. In first case, nitrogen is bonded to 4 hydrogens, right? In second case, nitrogen is bonded to 3 hydrogens and oxygen with hydrogen. There is a positive here, there is a positive here. In which case, your hydrogen is more acidic. Can you circle the acidic hydrogen here? Can you tell me which one is the acidic hydrogen? Any one of these? Any one of these 4? What is no 4? No, no. It's bonded to an electronegative atom, so it's acidic, dear. Aditi? Any one of these 4 are same. Any one. It's bonded to nitrogen. Can you see in the periodic table? Nitrogen is equally electronegative. It's slightly lesser than oxygen. Okay? So it is acidic. There is no doubt about it. It's acidic. Because there is a positive charge on this nitrogen. What happens when there is a positive charge, children? It will try to take away this electron density on itself. Nitrogen with positive means very electron hungry. So it's going to take away electron density on itself. Right? Any question here? It's not a normal nitrogen. It's not a nitrogen. If I give you this one and there is a lone pair here, if I give you something like this, then I'll say, okay, no, this hydrogen is not acidic. But when there is a positive charge, you have understood that positive charge means high oxidation number also. Correct? So when it has a positive charge, it's very, very electron hungry and it is acidic. What about this one? Here you can see 2 hydrogens acidic. One on the oxygen, one on the nitrogen, right? Now compare the structure of this and this. In which case you have more electronegative atoms? In which case? In which case more electronegative atom? Second, there is oxygen also. What this oxygen is going to do? It will pull the electron density from the nitrogen. And when it pulls the electron density from the nitrogen, what nitrogen can do? It can take electron density from the hydrogen and it will kick out this hydrogen as H plus. So taking away this hydrogen is much more easier than this. Agreed? So which one is stronger acid? Which one is stronger acid? This one, the second one. Stronger. Because there is oxygen also, which is pulling electron density from nitrogen. So nitrogen will kick out hydrogen as H plus. Now this one. In this, I'm not going to help you children. So we are talking about the hydrogen. These are non-oxoacids. So hydrogen on the electronegative atom is acidic. I'm talking about these are non-oxo, right? They are without oxygen. They are acids without oxygen. There is a plus formal charge. You know the meaning of formal charges. There is a plus formal charge. Which one is more acidic? Follow the rules of non-oxo acids. Okay, Azuni is already answering. Aditi, what's your answer? Is this the answer, Aditi, which you are giving me? Okay, Nivriti, good. So three students have answered. What about rest of you? Thinking? Afan, okay. What about rest? You know that these are non-oxo acids. So first you decide, are they in the group or in the period? These two elements. Are they in the group or period? Nitrogen and phosphorus. Check the periodic table in the group. In the group, as you move down the group, what are you going to compare? The size. From the size, you are going to compare bond lengths, right? From bond lengths, you are going to compare bond energy. From bond energy, you are going to compare acidity. Which one is easy to break, right? If bond energy is less, it's easy to break. Are you okay with this understanding? Okay, Afan, can you answer? What happens to the size as you move down the group? Who is bigger in size? Nitrogen or phosphorus? P. P is big size. Big size means big bond lengths, big orbitals, big bond lengths. Unit 2. Big bond lengths means low bond energy, low or less. You can write less bond energy. Less bond energy is very less amount of energy needed to break the bond. Less bond energy means easy to break away H plus. H plus moving out easily, breaking away easily. If it is moving out easily, then it means it's the strong acid. Can you write down the conjugate base of this and this? Conjugate bases. Give the conjugate bases of ammonium and phosphonium. Yes, I'm going to clear it. I'm writing again. So you said ammonium is weaker acid than phosphonium. That's the conclusion we made for D part. Now I started asking you to write the conjugate base. Ammonium conjugate base is remove H plus, Afan, subtract H plus. So what is it? NH3. Phosphonium is remove H plus. What is it? PH3, right? Okay, now tell me which one is stronger base. Which one is stronger base? Yes, this is strong acid. Strong acid will give you weak conjugate bases, right? And weak acids will give you strong conjugate bases. Are we clear about it? Bond length slide means the thing which I was writing. You're talking about that? Yeah, I can write here. Okay, Aditi, whatever question is there, please put it in the direct chat because because it's a recording going on. Other children are also listening, so they want to know what I'm talking. Put it in the direct chat. Aditi is saying that please go back to that bond length slide, which I didn't make. It was the writing part she's asking. I'm writing here again. Those who want to write down because it's important. That's why she's asking. It's very important, children. I'm writing here. Big atoms. This is based on size. Big atoms means big orbitals. This is in unit 2 also. Big orbitals means when big orbitals overlap, they give you big bond lengths. Big bond lengths. Big bond lengths means weak because if they are weak, attraction is less. Okay, Naisha, no problem. Big bond lengths means weak bonds. Weak bonds. Weak bonds means easy to break. Easy to break means more acidic. That you can take away or you can write here H plus comes out easily. Easily means more acidic. Write it like this. More acidic. And this trend, this we are going to think and discuss only down the group. Down the group. Okay, now ready for the next topic now, children? Can I move? This is what we did in the last class. So I just wanted to touch it again because what we are going to do, many things are related to this only. Ready? So Aditi, can I erase it now? Can I move to the next slide? Okay, nature of oxides. This is also something very important. And this we have done maybe in the periodic trends in unit 2 also. So now you can answer it, you can understand it better, but in unit 2, maybe you will be in difficulty in understanding of this. But now you know your acids and bases, you know the concept, so you can understand. We are going to discuss two types of oxides. One, metallic oxide. other non-metallic oxides. You know what are metals? What metals can do, children? How can you divide your periodic table into metals and non-metals? What is so special about metals? Mhm. Metals, we have done this metals in unit 3. Metallic forces, metals. What metals can do? Anyone? No, tell me the chemistry. These are the physical properties. They are shiny, they are malleable, they are ductile, they have high melting points, they are solids. All these are physical properties. What is the chemistry for metals? Anyone? Remember metals, non-metals based on whether they can lose electrons or gain electrons? Yeah, they have a sea of electrons. So what Nivriti metals can do? What charge they can have, Azuni? What charge? They can have plus charge or minus charge. They can lose electrons or they can gain electrons. Metals can lose or gain. Metals can lose. Remember that. Metals, they lose electrons always. Like sodium metal loses 1, magnesium loses 2, aluminum loses 3. Metals can lose electrons. So what non-metals can do? Non-metals can, yes please, can gain electron. Now, I'm asking questions from the periodic trends. You have any periodic table next to you? Okay. Now what happens to the size across the period? Like for example, if I'm taking sodium followed by magnesium, I mean in the period number 3, then aluminum, then silicon, then phosphorus, sulfur, chlorine, and then you have argon. What happens to atomic size across the period? Decreases. Very good. So sodium is very big and chlorine is very small, right? So which element can lose electron and which element can gain electron? Who can lose electron? Sodium or chlorine? So this is the nucleus, this is the electron. So nucleus and electron are far away. Attraction is less. You remember Coulomb's law? Coulomb's law, F equals to Q1, Q2 over R square. So as the size is decreasing, what is happening to the tendency of losing electron? Size is decreasing. What is happening to the tendency of losing electron? Yes, Afan, what do you think? They are losing electron easily or they are finding it difficult to lose the electron? I'm just trying to show you decrease size. Hmm. So it will become harder to lose electrons. See what Aditi is writing, children? Because as the size decreases, the attraction between the electron and the nucleus increases. So it is harder to lose electron. And what is easy as you move across the period? Is it harder to gain electron or easy to gain electron? Who can gain electron easily? Electrons are coming from outside. Who can gain electron easily? The one which are smaller. Okay, now answer this question. Okay, all of you please answer this first. Metals, they lose electrons or gain electrons? All of you please. Okay, as you move across the period, what happens to the tendency of losing electrons? As you move across the period, what happens to the tendency of losing electron? Decreases. Yes, very good, Aslisha. As the tendency of losing electron decreases, what happens to metallic nature? Period. What happens to metallic nature? Metallic nature is tendency to lose. If an element can lose electrons easily, it is more metallic. If it is finding it difficult to lose electron, it is less metallic. So, across the period, metallic character, yes, Nivriti, decreases. And what happens to non-metallic character? Non-metallic character increases. This is unit 2, periodic trends, meaning of the metals and non-metals. Can you explain the same thing I explained you on the period? Can you explain down the group? Down the group, like first group. First groups are very strong metals. Hydrogen, then lithium, then sodium, then potassium, rubidium, cesium, francium. Generally, we are not talking about them. These are radioactive. So what happens to the atomic size? Yes, so what happens to the metallic character down the group? What happens to metallic character down the group? See what Aditi is writing, children. Azuni, you're right. Down the group, atomic size increases. As size increases, the tendency to lose electron increases or decreases? Aslesha and Azuni. One is very big in size, other one is small in size. Who can lose electron easily? The big one, because the distance is very large. This R is large. Coulomb's law. It's easy to take away this electron, right? So what happens to metallic character? Afan, if you are getting confused, something is troubling you, you can ask questions. So down the group, metallic character increases. And if metallic character is increasing, what happens to non-metallic character? That decreases. Yes. Metallic character increases, non-metallic character decreases. I'm going to erase this and I'll ask questions. Okay. Sodium, aluminum. Which one is more metallic? Which one is more metallic? Only one answer has come. What about rest of you? Look at the periodic table. They are in the third period. First element is sodium and third element is aluminum. You want me to share the periodic table? Okay, 1 second. I'm sharing the periodic table. Then I'll ask some questions. So we are going to do this topic on the periodic table. Here. Ready? Okay. Let's write down period. Period means left to right. Period, left to right. Left to right. Size. Size increases, decreases. Answer this question now. Size increases, decreases. Because you're not answering questions, so I'm repeating everything. Size decreases. Metallic nature. Metallic nature. The tendency to lose electron decreases. Non-metallic nature. Non-metallic nature. increases. You're understanding this? Okay, now I'm saying sodium and aluminum. Check where are they in the periodic table. You can see them here. Sodium, you should be fast in searching your element. Do not waste your time in the exam in searching elements. So start using your periodic tables. Sodium and aluminum. Which one is more metallic? Yes, sodium is more metallic. Perfect. Okay, now I'm giving you another question. Chlorine and iodine. Chlorine and iodine, are they metallic or non-metallic? You can see that they are on the extreme right side of the periodic table. They are non-metallic, yes. Which one is more non-metallic? Chlorine and iodine. Which one is more non-metallic? Okay. Now we are in the group. Answer is wrong. We are in the group. What happens to the size down the group? Size increases. What happens to metallic character down the group? Metallic character increases. What happens to non-metallic character down the group? This is unit 2. Non-metallic character decreases. So which one is more non-metallic? Chlorine. Chlorine is more non-metallic than iodine. You are understanding this? Now I'm going to teach you the topic which we are doing as acids and bases. We are going to discuss, I hope you have written this, children. I'm going to discuss nature of oxides. Can I clear the whiteboard? Afan? Okay. Aditi? Okay, good. Now I'm writing here the topic, the name of the topic. We are going to learn this topic on the periodic table. Nature of oxides. You're going to identify your oxide as metallic and non-metallic. That is easy, right? I'll give you an oxide and you'll say, oh, it's metallic oxide or it is non-metallic oxide. Very easy thing. Okay. I'm giving you calcium oxide and potassium oxide. What are these? Metallic, non-metallic? You already know this thing also that if you put a staircase like this, on the left side you have metals, on the right side you have non-metals. This I think I told you earlier also when we were doing unit 2. Nomenclature, ionic compounds, covalent molecules. This we know, all of us. Yeah. So, what are these? Metallic oxides or non-metallic oxides? See, where are they? These are oxides, right? Calcium oxide, potassium oxide. What are these? Metallic or non-metallic? I'm getting very less answers. Is it difficult to identify a fan? Ariba, you're not answering anything. I hope you're there in the class. Ariba, answer. What are these? These are metallic oxides. Don't slow down the class. Keep answering, and it will help me in giving you more learning, more examples. If you stop the class, if you don't answer, then you'll see that I'm stuck here only. What are these? What are these? I keep saying this. So keep answering, right? If you write MO, you can use any abbreviation. I will understand. But answer, right? Which one is more metallic oxide? So they are here. Which one is more metallic, potassium or calcium? Potassium or calcium? Potassium is more. So this is more metallic, stronger metallic oxide. Now see what happens. When you add water in a metallic oxide, add water, it reacts. There's a reaction to give you a hydroxide. All metallic oxides, they react with water to make hydroxides. And what is hydroxide? It's a base. We know that. This one also. It also reacts with water to give base 2KOH. Is it clear? Aslisha and Nivriti, we are good with this? You know that hydroxides are any substance which gives OH minus in water is a base. It has a one negative charge. You look at the calcium. Calcium is in second period, is second group. You know that it can lose two electrons. So it's going to combine with how many hydroxides? Two hydroxides, like this. So that's why it's going to make this one. And potassium has 1 plus, hydroxide is 1 minus. So it's going to make 1:1 ratio hydroxide. This is how we make formulas. This is also base. So please write down. Metallic oxides, all metallic oxides reacts with water to give metal hydroxides. And these metal hydroxides are bases. So which one is stronger base? Strong metallic oxide, stronger metal, stronger metal. If metallic character is more, stronger metal will give you stronger base. And you remember that you were telling me that potassium is stronger metal. See, all of you are typing here. Potassium is. Yes, Azuni. See, children, what Azuni is concluding? She is trying to think in advance. I didn't ask any question and she is answering. She knows that's the next question. K2O is a stronger base. Stronger base. All metallic oxides are called as basic oxides. Basic oxides means metallic oxides. Means when you add them into water, they give you bases. Stronger basic oxide means stronger metal. Weaker basic oxide means weaker metal. Is this clear to all of you? Can I ask a question here again? Another question? Ready? Okay. This time I'm giving you rubidium oxide, and rubidium oxide is this, and cadmium oxide. What kind of oxides are these? Metallic or non-metallic? They are metallic oxides. Very good. So can you put this rubidium oxide in water? Can you complete the equation? Cadmium oxide in water. Complete the equation. You already know. I've given you metallic oxides react with water to give metal hydroxides. So work out the charges. What's the charge on rubidium? That you can work out from the periodic table. What is the charge on rubidium, children? First group. You are aware of that, right? +1. That we know from the periodic table. But how to work out the charge on cadmium? Because cadmium we cannot predict from the periodic table. So come back on the formula. This formula will tell you the charge on cadmium. What's the charge on oxygen, children? 2 minus. See oxygen from the periodic table. So what's the charge on cadmium? Yes, very good. Can you complete the equation? What's the product here and here? Complete it. You know the charges. You know the charge on hydroxide. Hydroxide is? Yes, 1 minus. Can you complete this equation? Combine this OH minus with rubidium. No, 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 Azuni. What's the charge on rubidium, Azuni? 1 plus. What's the charge on OH minus? OH 1 minus. What's the formula? Formula. This, don't worry about this too. That is with oxygen, that's why. What's the formula? 1:1 RbOH. Then you have to balance it. Yes, Ariba, very good. RbOH. Azuni, practice nomenclature. I think we did it in unit 1. Okay, can you do this part? Now you can see, balance this equation. Yeah, before we leave, balance. There are 2 rubidiums. So put 2 here and you can see that everything is balanced. 2 rubidiums, 2 oxygens, 2 hydrogens. Afan, can you give me the formula of cadmium hydroxide? Charges are here. OH minus. I just explained you everything. How to make a formula of 2 plus with 1 OH minus. Formulas are always neutral, no charge. So how many OH are needed? Yes, very good. CdOH twice. I think it's already balanced. Now, next question. Which one is stronger metal? Which one is stronger metallic oxide, basic oxide? Which one is more stronger basic oxide? Rubidium oxide, because rubidium is stronger metal. So it's more stronger basic oxide. In fact, it's one of the strong base, basic oxide. So it means rubidium hydroxide is a strong base. We know it already. Remember strong bases? I gave you a line for strong bases. Only first group hydroxides. These one. These are strong bases. Rubidium is there, including, yes, children, including 3 from here. I told you to memorize it. These calcium, strontium, barium, they will also give you strong base. So are we clear about the basic oxides? Metallic oxides are basic oxides. Please write down somewhere. Metallic oxides are basic oxides. Then you compare which one is more metallic. More metallic, more basic. More basic, more stronger base. Right? Anyone in trouble here? Nivriti, you're comfortable? Because you missed few classes. Nivriti, keep asking your questions. We all are here to help you. Those who have missed the classes and I have not uploaded the video, please remind me on WhatsApp because now I cannot delay uploading the videos because so many classes are going on. Okay, Aditi is asking a question, children. Can you answer this? Is it a double displacement or is just a combination reaction? It's a combination, Aditi. Yeah, it's synthesis. Yes. You can call it as synthesis or you can call it as combination. These two are just combining. synthesis or combination reaction. But I have a question. Is it a redox reaction? Is this reaction a redox reaction? You have done oxidation reduction in unit 4. Unit 9 is also based on the same thing. Can you check and tell me what is the oxidation number of rubidium here? If you look at the periodic table, it's +1, right? What is here? What is here? Oh no, Azuni, no change. They are fixed. First group elements are fixed. Still +1. Is there any change in oxidation number? No, it's not a redox reaction. This is very strongly tested in your AP exam. I want you to watch some videos where you go back to your unit 4. In the last of the unit 4, we are learning oxidation reduction, redox reactions. And we did plenty of questions based on how to balance, how to identify oxidation numbers. It's very, very important question. So you write on this. Again, I'm giving you a magic line. You can call them as magic lines, which are going to help you in the exam. Acid base reaction. They are just either they are double displacement, the way Aditi was saying, but here they are just combination, like this is oxide. They are never redox. Whatever acid base reaction you are doing, they are never going to be redox. Memorize it. It will help you in the exam. We are good with this? Oxidation number, Azuni, is the charge per atom, not on two atoms. Azuni is saying because there are two rubidiums, that's why she has taken +2. But my question was, what's the oxidation number? And by definition, oxidation number is the charge per atom. If two rubidiums are holding +2, then one rubidium is +1. Oh, no, no, don't say sorry. There is no need of saying sorry, children. We are learning. If you do these errors, I can see. You know, I generally tell students to do quizzes because I want to see what errors you are doing. I want to check your errors. I want to correct your errors. That is the reason I'm after you. Please answer, please answer. Don't worry about your wrongs. If you are wrong, only then if I see that you are wrong, only then I will correct you. Don't take this thing that, oh, I will be wrong and everybody will see that I'm wrong. No, don't worry about that. We are learning. Done? This part is done? You have written this line? If it repeats, can you answer? If I ask this question again, just see if you are doing acid base reaction, just without doing anything, just say it's not a redox. Okay? Okay. So we are doing the topic. What's the name of the topic, children? Afan, what's the name of the topic? Nature of oxides. And we discussed metallic oxides. What are metallic oxides? Acidic or basic? Metallic oxides are? What are metallic oxides? They are basic oxides. And non-metallic oxides will be then non-metallic oxides will be then acidic oxides. Means if you take a non-metallic oxide, add water, you will get an oxo acid. And for the oxo acid, you are going to use the same rule. Oxidation number of the central element, On. You remember On, oxidation number, and the electronegativity. More higher oxidation number, more electronegativity means more metallic or non-metallic, sorry. These two will make them more stronger acid. Stronger acid. Ready for examples? Now I'm going to give you some examples. Work with me. Can you give me an oxide of carbon? Popular oxide of carbon, which is all around you, in you, out you. It is there inside you. Yes, carbon dioxide. So when you put this carbon dioxide in water, just do combination, just like combine them. And it's an acidic oxide, so hydrogen will be in front. Just mathematically combine. H2CO3. This is oxo acid. It's called as carbonic acid. Carbonic acid. Right? Okay, now let's add this NO2 in H2O. Then I'm getting, actually here we need some oxygen also. So what is the oxidation number of nitrogen here? Plus 4. Some oxygen is also needed. It's a very unique reaction, so don't worry. You just write down, this is the acid which we are going to get, HNO3. Check the oxygens are balanced. You have to take half here. Half here. 1/2. Like this. Now it is balanced. 2 hydrogens, 2, 3. Oh, no, still not balanced. Can you balance the oxygens, children? In this reaction, this is very unique reaction. If I put 2 here, then there are 6 oxygens. Then I have to put 2 here. And then I'm going to put 1/2 O2 here. Now it is balanced. What type of oxide is this? Non-metallic. Which one is more non-metallic oxide? CO2 or NO2? Which one is more non-metallic oxide? NO2. So which one is stronger acid? Which one is stronger acid? HNO3 is stronger acid, right? So I'm giving you plenty of examples now. You're already aware of your oxoacids. Check. I have given you a list of acids also. If it is not there, I will put those lists there on the website. You can download from there. Remember last time I was telling you that generally all these oxygen containing anions, polyatomic ions of oxygen, they all make oxoacids, all of them. Like for example, HClO4. You can get HClO4 by mixing Cl2O7 with water. The equation is balanced, perfectly balanced. And there is no change in oxidation number. Chlorine here plus 7. Here plus 7 is not a redox reaction. Cl2O5. Add water. You will get the next acid HClO3. Perchloric acid, chloric acid. You take Cl2O3. Add water. You will get 2HClO2, hypochlorous. Here this chlorine is +5. This chlorine is also +5. Here this chlorine is +3. This chlorine is also +3. Then you take Cl2O. This is +1 plus H2O, giving you 2HClO. This is also +1. All these are acids. All these are non-metallic oxide. And you can see that in non-metallic oxides, if the oxidation number, here chlorine is not changing. Same chlorine here, 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 here. Same chlorine. What is changing? Anyone? What is changing? I'm circling what is changing. What are you going to call it? What is changing, Azuni? Nivriti, Aslesha, what is changing? Aditi is answering. Very good, Aditi. Oxidation number. And if oxidation number increases, what happens to acidity? See here, it's an oxo acid. It increases. So which one is the strongest acid here? HClO4, then HClO3, then HClO2, then HClO. This is how the acidic strength is decreasing. Why? Because here chlorine is +7, +5, +3. You can calculate the oxidation number the way I discussed in the last class and check it yourself whether I'm right or wrong. Ready for the questions on nature of oxides? Now we are going to do some questions. Okay. I didn't discuss with you neutral oxides. What is a neutral oxide? Because AP will not be asking about it. So that's the reason I avoided. But yes, there are some neutral oxides. Neutral means when you put them into water, they will not make any acid or base. So the popular neutral oxides, those who are interested in learning slightly more, they can write down in their notes. Neutral oxides are like NO, it's neutral. CO, N2O. These are these are the important neutral oxides. When you put them into water, nothing happens. They will not make acid or base. What can be the reason? If you look at their Lewis dot diagrams, they have triple bonds. So we are not going into the in depth about neutral oxides. Can you answer this question? Yes. What is this? Acidic, basic, or neutral? Just tell me whether it is acidic or basic. So check. Is it metallic oxide or non-metallic oxide? Afan, try to answer. Go step by step, Aslisha. Look at the periodic table. Check where is this Ca. And then decide, is it a metal or non-metal? And then answer. Remember metallic oxides? I was writing that. When you add metallic oxides into water, what's the product here? Can you give me the product? Check the charge on calcium. Again, Aslisha, charge on calcium is 2 plus and OH is 1 minus. So the product is, yes, Aslisha, you're getting it? And it's an hydroxide, it's a base. SO2, metallic, non-metallic. So when you put non-metallic oxide in water, what are you going to get? Acid or base? What's the formula? Just combine them. Put hydrogen in front. Just combine mathematically. For acids, hydrogen will come in front. Yes, 2 plus 1. Sulfurous acid. Okay, now let's take this Cl2O plus water. What is it? Metallic, non-metallic? So acidic or basic? And when you put this into water, you will get HClO. So here chlorine is plus one. I think I told you to memorize this series. We did the nomenclature. This is hypochlorous acid. Check in unit one when we are learning all these nomenclatures. I have given you these series of, we call them as oxygen containing, halo means halogen, ions. And from there you are making acids because halogens are non-metals. So when you put them into water, they all form acids. Okay, ready for this? Now try to answer. Think like this. First, check lithium, metal, non-metal. Then think, is it metallic oxide, non-metallic oxide? Then think, is it basic or acidic? Then add water. And then think, if it is basic oxide, it will give you hydroxide. OH will come in the last. If it is acidic oxide, hydrogen will come in front. So, lithium, metal, non-metal. Afan, lithium. If it is metal, what kind of oxide is this? Metallic, non-metallic? If it is metallic oxide, is it basic or acidic? If it is basic oxide, when you put this basic oxide in water, what are you going to get? Can you give me the equation? They are asking you to write the reaction. What's the equation? What's the equation? Yes, it is lithium hydroxide. And you're going to place 2 here, right? What about CO2? Metallic, non-metallic, metal, non-metal. So non-metallic oxide. So acidic, basic. Acidic oxide, when you put them into water, you get an acid. What's the acid we are going to get here? H2CO3. Okay. SRO. Metallic, non-metallic. All these are, you can call these reaction, they fall in the category of acid base reaction also, and they are combination reactions. Water. It's metallic means basic. So what's the product? Check SR in the periodic table. What is the charge on SR, Nivriti? Nivriti, what is the charge on SR? Strontium plus 2. So with OH minus, what's the formula here? Yes, Nivriti, can you try the formula? Aslesha, you try the formula? Afan? I think Ariba is good with writing formula because children, Ariba was doing quizzes earlier, 1, 2, 3 units. I think she did very nicely. So if I'm not asking her what's the formula because I know she knows. If you do something, then you retain. What's the formula? Yes, Asuni, very good. Strontium hydroxide. Take the quizzes as a part of learning, not as a part of test. Don't think that it's a test. It's not a test. It's learning. You're learning topic and then you are practicing it as a quiz. And don't worry, you are getting 0, 1, 2, 3, 4, or 10. It doesn't matter because you are learning there. You can do it twice, thrice. Okay, so that's about your acidic oxides and basic oxides, metallic oxides and non-metallic oxides. I try to discuss in detail, in depth. I covered the periodic trends also. I made you understand metals, non-metals again, and how this metallic character increases, decreases. Then accordingly, how can you decide which one is more stronger base or more stronger acid? Okay, common ion effect you have done earlier with me. Now we are left with less time, but I want to cover this common ion effect. And in the next class, we'll be starting buffers. Okay, let's discuss the common ion effect on the equilibrium. So when I say equilibrium, what should I take? Strong acid, weak acid? What should I take for equilibrium? Please answer this. Equilibrium is there in strong acids or weak acids? Yes, anyone? Remember we did how to calculate the pH of a weak acid, pH of a strong acid. So in which case we were writing the equilibrium? In weak or strong? Which one is not 100% dissociated? Hmm? Afan, you're listening? Weak. Why? Because weak is not 100% dissociated. Don't tell me that children, you're not able to recall that. See, before these oxo acids, we were doing pH of weak acids and weak bases. We did so many questions. The Ka values are mentioned here. These Ka values are only for weak acids and weak bases, Ka and Kb, not for strong. What is the reason why we don't have Ka and Kb? Sorry, one second. Why we don't have Ka and Kb for strong acids and strong bases? Anyone? Because they are, yes, please. Yes, Aditi, very good. 100% dissociated. There is hardly any undissociated form. So no equilibrium, single arrow, right? So when I say I want to learn the common ion effect on the system, then it means I'm going to deal only with weak acids and weak bases. Will not take any example of strong acids or strong bases. So let's take a weak acid. You remember all carbon containing acids are? Yes, all carbon containing acids are weak acids. Weak acids are soluble in water, but they are not 100% dissociated. So there is an equilibrium. HCN is a weak acid. Can you see the equilibrium here, children? This one. So finally in the solution, all these are present. This, all of them are present. Okay, now to this solution, I'm adding KCN. What is KCN? Remember the solubility rules for the first group? First group compounds are always soluble. Unit 4, they are 100% dissociated like this, right? They are 100% dissociated like this. When I put this KCN in the solution of this weak acid, they are added together. Now, do you remember the Lee-Chatelier principle? Now, this Cn minus and this Cn minus, now in the solution, there is plenty of Cn minus, plenty and plenty. Because the Cn minus is coming from here. And Cn minus is the common ion. So this is increasing in excess. It is in excess. in which direction the equilibrium will shift. It can shift to the left or right. Now, when you add this common ion containing compound, common ion, the Cn minus, which is the part of your equilibrium, common ion, see, it's the part of this equilibrium. In which direction the equilibrium will shift to minimize this change? To the left. Afan, to the left, agreed? Nivriti is shifting to the left due to common ion. If it is shifting to the left, are you going in the direction of dissociated or undissociated? In which direction you are going? The dissociated form or undissociated? Undissociated, yes. Can I say that the reaction is going in the direction of less ionized form? This is ionization, ionized. This is not ionized. Can I say that? Everything? Ionized, not ionized. I'm calling it as not ionized. I'm calling it as ionized because there is plus minus. You can see ions are there. Okay, so if my reaction, if my equilibrium is shifting in the direction of undissociated acid, then is this helping this acid, to make it more stronger or more weaker? Please answer this. The HCN is becoming more stronger or more weaker acid due to this common ion effect. My question is clear? The question says due to common ion. Which common ion we have added? Cn minus. Is it becoming stronger or weaker? Is the acid becoming stronger or weaker? That's the question. Stronger means more dissociation. Weaker means less dissociation. That you know already. So is this HCN due to this common ion Cn minus shifting to the left, which is very clear to us, is it becoming more stronger acid or weaker acid? Answer it. Aditi, can you try? Nivriti, Aditi, Aslesha, Azuni, try it. Okay, Aditi is saying weaker. Azuni is also saying weaker. Nivriti, what do you think? Aslesha. Afan, what do you think? It's weaker. Why? Because it is undissociated now. It's not giving you H plus. The amount of H plus is decreasing. Yes. Afan, can you ask your question? If you are not sure, ask your question. When it is shifting to the left side, what is happening to the concentration of H plus? There are so many ways of understanding. What is happening? It's decreasing. The amount of H plus is decreasing. If amount of H plus is decreasing, it's becoming weaker, isn't it? Because the concentration of H plus tells you whether this acid is strong or weak. If you are getting high amount of H plus, strong acid. If you are getting less amount of H plus, weak acid. Right? So I'm giving you one particular statement here. I want you to read it. And just let me know, are you clear about it? The presence of common ions suppresses the ionization. So if there is a weak acid Ha, which is undergoing dissociation like H plus and A minus, if I add this A minus from outside, A minus from outside adding, then according to Lee-Chatelier principle, my equilibrium shifts to the left in the direction of unionized. So when you add a common ion, there is suppression of ionization. Suppresses the ionization. It shifts the equilibrium in the direction of unionized form. Are we clear about this word? So children, I'll see you then in the next class. In the next class, please join at the right time because I will be starting buffers. Okay? See you in the next class. Bye. Okay. Nivriti, you have any question? Azuni?
I think maybe I did have a question. So
Mhm.
for the one where you had an example of CO2 and H2O,
Mm,
I think.
yeah. So
Um,
CO2 reacts with H2O
yes.
to give, it's a non-metallic oxide, right?
Yes.
H2CO3. If
Oh,
you if you see, you have to just practice how to calculate oxidation number, which I think I told you in the last class also how to do it. Just watch
yes.
the video. This is +4 here, and here also it is +4.
Okay. I think I was thinking of it the other way around because
Like,
I thought because I was getting confused because I thought we were starting with H2CO3 because then it, wait a second.
yeah, there is a reaction like this also. H2CO3 is a very weak acid and it's a very unstable compound. When you heat it strongly, heating, decomposition, it gives you H2O and CO2.
Okay.
You know,
Because I was,
decomposition and synthesis are reverse of each other.
yes. I think I was thinking of combustion because we just learnt that in school. So,
Combustion is already in the highest oxidation number. You
yes.
know, combustion means carbon getting converted into carbon dioxide.
Yes.
When you do the combustion of carbon dioxide, nothing will happen
Yes.
because
Okay.
you look at the periodic table. How many valence electrons carbon has? 1s2,
Um,
2s2, 2p2. That's the normal configuration, right?
yeah.
4. You know, maximum oxidation number carbon can have is +4, not more than that
Yes.
because of its valence electrons.
Okay.
So that is the reason CO2 is the most oxidized form of carbon. So you cannot do its combustion. Combustion is not necessary that everything will burn. If there is CO2, there is no burning,
Okay.
right?
But if it's CO2 and H2O, then,
No, H2O is also no burning.
oh,
Do you
wait,
think
what?
water burns?
Oh, no.
Yeah,
Wait,
because
then why?
hydrogen is,
Oh,
yeah.
that's what our teacher said. Like, if it was like C, I don't know, what, like, whatever it was, like
Oh, no, no, she must be
CH3
saying that
plus
they are used
O2.
for extinguishing the fire. CO2 we
No,
are
they said
using.
it was, they
Mhm.
said it was made to burn fire.
No, maybe you may have heard something wrong because we all know that how to stop a fire. You spray water.
Yes.
How to stop a fire? You spray CO2 gas. You remember that fire extinguisher, that red one?
Yes.
You know what is there? In that there
What?
is sulfuric acid H2SO4 with some compound like calcium carbonate.
Okay.
I think they use some sodium hydrogen carbonate which can give you a large amount of carbon dioxide. And there
Okay.
is a very popular reaction that all acids they react with
Okay.
carbonates and hydrogen carbonates to give CO2. So
Okay.
when you take out this fire extinguisher and you are just inverting it, then this cup of the sulfuric acid breaks down. Then it combines with sodium hydrogen carbonate. And this cylinder is now full of CO2 gas. So when you press the nozzle, CO2 gas comes out with a great force and it makes a blanket on the burning object,
Yes.
CO2. And here's the burning object.
Okay.
CO2 is not combustible. It cannot undergo combustion. Carbon is already done. Carbon cannot be further oxidized. So this CO2 is breaking the contact of the burning object with the air. Air is now outside.
Okay.
And if there is no contact of the burning object with the oxygen of the air, burning will stop.
Okay.
So maybe he or she must be saying this. They cannot do such a big error, Azuni.
I don't know. Probably. I probably maybe heard it wrong or something. I don't know.
Yeah, I have seen many times children they heard it wrong most of the time
Okay.
because you are learning. You have your things are going in your brain. Sometimes I'm saying something. I have seen children answering it in the wrong way, exactly wrong way. And nowadays I'm not surprised by this because I have seen this is the tendency of most of the children.
Yes.
Till the time it's not repeated. Can you see that my repeating capacity is very high?
Yes.
Because I know children they take things in the wrong manner.
Okay.
Okay, so don't worry.
Thank you, Miss Sharma.
Yeah,
Thank you.
but today I told you something very good. So retain it. This carbon
Okay.
is +4. So please do not try to burn CO2 or water.
Okay.
They will not
Okay.
undergo combustion. Okay. See you
Okay.
then.
Thank
Bye.
you.
Bye bye. Anil, you have any question?